Yes, sir.
Okay, okay. So we'll start now. Today is the GIS, some basics practical is there. Okay. Screen is visible?
Yes,
Yes,
sir.
ma'am.
Yes, sir.
Okay. So you have any experience, GIS experience or new to this field?
सर है एक्सपीरियंस में अभी रिसेंटली गुजरात फॉरेस्ट डिपार्टमेंट में कॉन्ट्रेक्चुअल बेस पे जीएस
अच्छा
एनालिसिस।
आपका
जी सर।
फॉरेस्ट डिपार्टमेंट में है नहीं?
जी जी।
ओके ठीक है अभी 2 इयर्स का एक्सपीरियंस है शायद।
सर ज़्यादा है, मेरा तो 15-16 साल का एक्सपीरियंस है।
15-16 का है।
2006 से हूँ सर मैं जीएस।
अच्छा तो
जी
आपको तो ज़्यादातर सब कुछ पता होगा।
जी जी सर।
ओके फिर भी देखिए आपका जो मतलब सिस्टम है उसके हिसाब से चलना पड़ेगा।
जी सर।
ओके नाउ दिस इज द विंडो ऑफ आरजीएस सॉफ्टवेयर। तो उसमें हम लोग जितना भी एडिटिंग पार्ट है तो इसमें some लेयर्स जो है डिफरेंट टाइप ऑफ लेयर्स raster layers and vector layers all are included in this table of content. So it is from the window tool in the ArcGIS software, that is table of content. Then create feature if we want to draw any features like point, line, polygon. Then we have to create something, and then it is under editor tool. So it is not editing, that's why it is not open. That is create feature. So now you just go through all the software tools and some operations in ArcGIS software. So basically, just I want to visualize some satellite images and some editing part. So that is Lancet 5 thematic mapper Lancet image. So there are 7 Lancet bands are there: blue, green, red, infrared, near infrared, sort of infrared, thermal infrared, sort of infrared 2. So these have all different wavelength from lower wavelength to higher wavelength. So generally blue is lower as compared to green, then red. So the penetrating power of the different particle is more if the wavelength is high. Then the resolution, that is a spatial resolution. So the pixel dimension is 30 meter, 30 into 30 meter for band 1, 2, 3, 4, 5. Then after this, the thermal and photo infrared bands, and as thermal has the highest resolution in this band, then photo infrared 30 meter. So we have to take these satellite bands to create some composite satellite image. So we have to exclude this band 6 as it is very high resolution, sorry, very low resolution. That's why we just add some bands like 1, 2, 3, 4, 1, 2, 3, 4, 5. So that is band 1 of Landsat satellite image, which has 30-meter resolution. So we can measure the pixel value. This is the 1 pixel and the dimension is 30 meter and 30 meter. So this is measure tool. So we can measure in terms of distance in meter. So this is 30-meter resolution. So it shows 30 meter. That is 30 into 30 meter. It is a 30-meter resolution. So it is a blue image, blue band image of a hilly terrain. Then another is green. So it's looks slightly different. Then it is a red band. So and another is infrared band. So in infrared bands, the satellite images looks very different as compared to other bands. So basically, infrared bands are useful for the extraction of water bodies. So previously, we just I read this phenomenon that the infrared bands absorbs more and absorbs more and reflect less. So in these water bodies, the absorption is very high in the infrared spectrum. That's why the reverse water area is very significantly demarcated as compared to other features. But in other bands, it is not possible. So this is the difference, and also vegetations are also clearly visible in this band. So for flood area mapping and other water bodies analysis, we use this infrared band. This all black spots are all are water bodies, and these water bodies are these are oxbow lakes. So previously, and this is the original channel of this river. These are the original channel of this river. So it is flowing like this. So these are all oxbow lake. So in this area, we have to join all these bands. So we can use image analysis tool. Then we can add. Okay. Then just click on the composite band in processing tool. Then this is the mosaic image of the Landsat. So all these bands are mosaiced in these composite bands. Six bands are included. So this is the false color satellite image. So the red color which are shown in this image are all are vegetations and forest area. So these are some forest areas, and these areas are some vegetation cover and some village forest area and small forest areas. And these are some agriculture fields. So from this process, we can composite all these satellite images of different bands. We can download all these Landsat satellite image. Then we can join. Then we can clip as per our convenience. So there are three point line polygons features of the vector data are there. So suppose I have some latitude and longitude information, like this is I have some latitude and longitude information, that is 21.57 and 87.38. So in this latitude is in plotted in the y-axis and longitude is in the x-axis. So suppose I want to create a point which I have some information about this point, like that is geographical information, that is latitude and longitude. So if I have some information, then I can create a point by using the R catalog, that is R catalog tool. Then just right click in the new, then save file. Save file is one of the vector data format, like DWG, drawing files, and other data. Then we can create some point location. Then we have to give the coordinate system. So without any coordinate system, there is no reference and there is not useful for the vector data. So we just click on the edit. So there are two type of coordinate system, that is geographic coordinate system, that is x 3D view, and for projected coordinate system XYZ. So suppose I want to give some geographic coordinate system. Then WGS 94 is our uh, projection system, and all the informations are there, like semi major axis, semi minor axis, information about that. Okay, then okay, so the point is created. So we can change the different symbol, then just right click, editing. So we just we can click anyone in this satellite image, but I have some latitude longitude information, so I have to give the information to plot in that area. So this is the format, then right click, then decimal degree format is there. So my point is in decimal degree format, it is not in degree minute second. So latitude, then we have to give latitude information, then longitude information. Okay, then we have to enter So the point is created which have an FID, the features ID, that is it is started from 0, then it's gradually increased 1 2 3 4, then the shape is point, then ID, it is a unique ID, so it is also started from 0. So these IDs are unique to all these features. So this features is located in this area. This is the exact location of the point. This is the point. So we can likewise we can get all the latitude longitude information from our mobile or from different GPS. Then also we can use this technique to plot all this point data or any polygon data or line data. But if you have any GPS receiver, then we can directly connect to the system. Then it is also directly collected all this information, then convert it into shape file or other KML file. Suppose I want to give this information to KML format, then we have to convert this point file into KML format. KML is nothing but that is a one type of format which is used generally in Google Earth satellite and Google Earth app and software. So the full form of the KML is keyhole markup language. So we have to export it in savage layer. Then there is a tool, there is a conversion tool is there. So from this conversion tool, we can convert this layer file to convert into KML file. This is the tool to KML. So layer to KML. So our layer file is in the D drive. Point location. Then output. Then the output is this file which is saved in a different folder. We can save in different folder. Then the output scale we can give it as a 5,000 or 10,000. So in this scale we can view. So it is completed. Now we can view in the Google Earth image. So this is the point which is shown in the Google Earth Pro. It is in the Odisha near the Subarnarekha river. So by clicking all, there is no other informations are there. The total attributes are seen, but there is no new attributes are created. So there is no information provided. So we can change this point to different symbols are there. Then there is the information, that is latitude, longitude information we have found in this software. So we can name it anything like some one data or other data. Suppose this is, I think, graph found area. This type of information is there. So this is the conversion. So we can also convert all these Excel information, into zip file. Basically, these are all in Excel format, and it is called as non-spatial data. So if I want to convert it into spatial data, then it should be in the point, line, and polygon in the GIS software in form of different format like shape file or KML file or other related file, but it should be a georeference file and in the vector format. So we have to convert it directly, but before that, the latitude format should be in this format, latitude decimal degree, and longitude also in decimal degree, but there is no other format are useful in this software like a degree minute second. So if degree minute second is there, then we have to convert it into decimal degree. So just add it, this Excel file, just go to the file, then add data, add XY data, then just so X field is longitude and Y field is latitude. Then we have to go to the projection, geographic coordinate system, world 1984, then OK. So all these informations are converted into shape file, that is point file. So this is our shape file, and so we have to convert it into shape file, that is called export data. Then it is exported to shape file. So all these shape files have some attribute which the Excel, in this Excel data, the information is same as compared to this shape file. So all the information we are getting with the help of this format. Then all the GP, village, block, and fish value added information are there in the point format. Then latitude, longitude informations. All these informations are the non-spatial data information, and it is called as attribute. So all these attributes which are present in the Excel format file, all are seen in this file. So same informations are there. So we also convert it into Excel file. So just click and paste all the information. Then it is also pasted in the Excel file. Like suppose it into different format and also used for different purpose. This is one of the example, and one thing is different satellites. I want to show you different satellite images. So this is a LIS4 satellite image. So you have three bands we are using in this LIS4 satellite image. So LIS4 have general something high resolution as compared to other satellite image. It is a commercial satellite image. It is not free of cost, and its high spatial resolution is 5.8 meter. Means the pixel value are 5.8 into 5.8. So it is good for urban work, urban mapping, and other geological mapping, and mangrove plant identification. It also very much useful. So why this is useful? Because it is a false color composite, and there is an infrared band which is very much useful for mangrove classes identification. For example, suppose mangroves are generally a evergreen forest. So in this area, so this is the area which is presence of mangrove forest. This is the mangrove forest area, which are salt tolerant species, which generally found in the coastal area, in the mud flat area. So it cannot be survive in the fresh water. So this is the one of the most important species, which is mangrove species. So it is very much helpful for protecting the land from different cyclone and flood. So this is the mangrove forest. Nearest to this, there is a Casuarina forest, cashew plantation. Casuarina plantation is there, and some of the area cashew also present. So this is Casuarina plantation. So the tone is very bright tone is there for mangrove, and it is not as compared seen same as compared to the mangrove forest. So we generally identify the mangrove forest. These are not mangrove forest. These are not mangrove forest. So these are some mangrove forest. These are Casuarina plantation, and another mangrove patches are there in the mud flat region. These are some mangrove forest. This is the mud flat area, and these white patches are all sand beaches are there. These are also Casuarina plantation. This is also mangrove forest. These areas are mangrove forest. These are all Casuarina plantation. These are mangrove forest. So likewise, we can identify different species based on different satellite images and their bands. And these are some. These are some all aquaculture pond. These are all aquaculture pond, which are used for the shrimp culture. These are all these areas are aquaculture pond. These are all aquaculture. So in the coastal area, very dynamic features are there. This is one thing we found that there's a creek. Then the creek are developed, which are opposite to the drainage system, because generally the drainage is flowing from higher elevation to lower elevations. But in the creek, the lower elevation to higher elevation, it is moving. by the help of the tidal effect. So these are some creeks are there. These are creek. So it is look like some drainage pattern, but it is a creek and it is a saline water. These are also creek. This is also a creek. These are all creeks. So these features are only found in the coastal areas. But after this boundary, the creeks are not present. If the saline water effect to these areas, then the creeks may be present. But if the saline water is not present, then the tidal influence is not there, and there is no creek develop in these areas.